Rangers and ¿Listos? No. This is not clean, right? Okay. Cube root of cosine of 2, which I have no idea what that is, but cosine of 2 minus this step part 0, yeah? So did you get something like the cube root of the cube root of cosine of 2 squared minus 4 times negative sine 2? Yes? What? What? What did I do wrong?
So inside the square root, it's t to the fourth minus 4. Instead of
Oh, I copied it down wrong?
yes.
Oh, well, let's just go with this, shall we?
Yes.
Okay. There you go. So your answer probably will not match the back of the book. So be it. Okay. How about 23? Are you done with that or not yet? Sorry, I didn't understand that. Yes, you're done or no? Thank you. What's the 2-word title to that second problem as far as type? Good try. Logarithmic differentiation. Logarithmic differentiation.
So is it
Starting the testament is Tuesday.
Correct. Is that about what you have? X e to the 2x, x to the e to the 2x squared times the quantity e to the 2x squared over x plus natural log of x e to the 2x squared times 4x. Yes?
Yes, actually, yes.
Cool. Logarithmic differentiation, go. I will say this. If you get a question like this on the AP test, the averages are usually very high. But a gotcha question is if they said just this. Now, it might feel like it's the same to you. Maybe it is, I don't know. Why would that be substantially harder? And I'm talking half as much success. Why? Because there's no why. That little change of, hey, there's two sides to this, makes results drop considerably. So if you have an easier time with there being a y on one side, then what should you do to start? Make a y to each side. Make it a logarithmic problem. The first thing you do is say, let y be that inside thing so that I can use logarithmic differentiation. You need to sometimes do that little extra step to make it a problem that you're comfortable with. You with me? Okay. All right, so today, this is typically be a Calc 1 problem, piecewise integration. There's easy ones and hard ones, and the word problems are hard. So I have the front side is kind of like the book would do, but the back side is more like AP practice. So stick with me, and I hope they're all well chosen, and it'll add to your understanding. The first one, you have this piecewise function f, and you're integrating f. The first thing when you have a piecewise you should do is check for continuity. Now, when I say check for continuity, I'm not saying do it in a nice formal, showing one-sided kind of way. Just as a mental check, is it continuous? The left side, what does it approach? 1. And the right side, what does it approach? 1. And so it's a yes. Now, if it's continuous, then no limits. Then no limits necessary. In other words, I can just integrate this by saying the first branch from 1 to 4, I can just use 4 of x dx. The next branch from 4 to 5, I can use the other piece to the piecewise negative x plus 5. I can just integrate, add the two separate areas, and boom, it's just really like two algebra problems or two area problems separate. Are you with me? Negative 1/2 x squared plus 5x from 4 to 5. So maybe 4 natural log of 4 minus 4 natural log of 1 plus negative 25 halves plus 25 minus negative 8 plus 20. So 4 natural log of 4 is fine. What's the area under the line come out to be? I guess I could have done that geometrically. That's okay. What is negative 25 halves plus 25? 12.5. And the other part is minus 12. So 4 natural log of 4 plus a half. Do you agree? Yes? Okay. All right then. Unfortunately, sometimes, now this is pretty uncommon in AP, but in college it's pretty common. If it's not continuous, then it's a bit of a mess. You should do it something like this. Let's go here. As you approach this time, it's obviously still 1 from the left side, but the right side is now more like, did this come out to be this? What did I do wrong here? Oh, sorry, negative 1, yeah? I thought it was continuous, but it's not continuous. It's not continuous.
Yes.
Okie dokie then. To do things well then, you have to deal with the discontinuity. If I were to graph this, it's 4 over x up to and including 4. And then the other guy is at negative 1 with an open circle and going down forever. Right, now, we obviously have a discontinuity. If there's a discontinuity, you must deal with it well. Now, let's start with the left-hand side. Can I just do a single integral from 1 all the way up to 4 inclusive? Boom. Can I do that? No, that's true. You can do it. This is equal to the limit, no limit. Darn it, I just tipped my hand. The integral from 1 to 4 of 4 over x dx covers that integral, that region, because it's defined and continuous, including the endpoints over the whole interval. Are you with me? Mm-hmm. However, the other guy is not inclusive of the endpoint, and so what do you reckon we must do to deal with that in a good calculus way? A limit. Let's create an A and talk about as A goes to what from where? 4 from the right. The limit as A goes to 4 from the right. From what limits of integration? A to 5, the upper limit. And that branch is negative x plus 3. And when you have a discontinuity, you have to deal with that way. When discontinuous, you'll need to use a limit. Now the good news is that on a multiple choice question, if you didn't use a limit and just mindlessly cranked out the pieces like it was continuous, you would actually get the right answer because there's no asymptote behavior here. Now remember, when we have an asymptote, if we were, for example, to just mindlessly crank out the antiderivative of this without addressing the discontinuity, you will get the wrong answer in many cases if you just ignore it. On cases like this, if it was multiple choice and they weren't looking at your work and you just integrated pieces, you'd actually get the right answer. So from there, you'd integrate and do your stuff. And do the, are you good? Okay. All right. Oops. One more type of piecewise. Now, it's not explicitly given piecewise, but you know when you have absolute value, it leads to piecewise. So, say you had a case where you had absolute value in the function and you were integrating absolute value. Absolute value is typically piecewise. So let's go to the piecewise version of this. Tell me, what does this graph look like? What do you think the big dividing line is between at what x? At 2. I think at 2 we're going to have some different behavior. Left of 2, what's the function? Just try it out. Put in -1. Plug in 0. At 0, what do you get? +2 over -2, which is -1. Now, is that going to be true for every point? It's going to be the same value, but by virtue of a different sign. Yeah? Try 1 if you're not sure. 2 minus 1 over 1 minus 2, that's -1. On every point on this side, it's always -1. At 2, it is undefined. I can't actually include 2 because that is indeterminate. And what about on the right of 2? It is just straight up 1, but again, not included. Now, because it's discontinuous, I must use, when I go to integrate, a limit approach. Just give me your setup of the limits, please. Limit as a goes to 2 from below of, or from 1 to a of, what's the function in that region? Negative. I think I'm about to die a very slow death. Are you maybe overthinking it? You can't tell me what the equation of this is?
Yeah. 2 minus x over x.
Why are you thinking so much? Let's go with -1. How about that? Do you agree?
Yes.
Okay. Am I making it too easy, or is it actually that easy? You made me cry my contract. It's -1. Yeah? Okay. So, plus the limit as b goes to 2 from above, from where to where? A to b to 3 of, see if we do better, 1. That's the spirit. Yay. Now I would probably just do those after I had the work set up properly, I'd probably just do these geometrically. What is the area from 1 to 2 here, just geometrically? Those negative y values are like positive y values. So that's negative. Okay? What about from 2 to 3? Positive 1. And therefore this is 0. Okay. Well, let's try doing some on your own. This is from a free response not too long ago. Actually, it was about 10 years ago. Try this and see how it goes, and we'll go over it. Feel free to talk it over with your math amigos, but do it beautifully, please. That was an AP problem, so they are talking about going from the definition of continuity on that part A. You needed to show one-sided limits and the point, or else you would not have got the points AP stuff. Like that. That's the definition of one of the definitions of continuity. If you don't show that, they will not even look at it. You get nothing. It's the definition of continuity.
If you put in like.
If you put in the function
Yeah.
itself, oh, that's fine. Yeah,
Oh,
yeah.
okay.
Yeah.
If you just did that without inversion.
If you picked up here, they wouldn't look. They'd give you nothing. I'm not sure. If they don't see a limit of the problem, they will not even look.
If you write that whole thing that you wrote, and that's it.
And then you go to the numbers.
Yeah.
That's fine. Which is 1 minus 0. Do you find them to be all the same? How we doing?
How do you know the cosine of -2?
How do I what?
No.
Oh, I was thinking cosine of 2 pi, wasn't it? You're right. 1/2 cosine of -2. You're right. Absolutely. So that doesn't actually come out. So, all right, here we go. Sorry, I'm getting it. 3/2 minus 1/2 cosine of -2 minus 1/2 or 1/2e squared plus 1/2. So that's pretty good, although I guess the 3/2 can combine. So maybe 1/2 of 2 minus 1/2 cosine of -2 minus 1/2e squared. How's that grab you? Sound good? Okay, something like that. You can see that would have been a bit of a time eater on the AP test, but it is what it is. Okay, technically you would have been, if you left it stopped there, you would have been fine. I didn't talk about part B yet. It was part of the continuity part of A fine. Yeah?
Yeah.
How about B? Did B go okay? Yes? Okay. I actually was hoping somebody would see a mistake in me. There's a mistake in me. What is it? What? So you're saying the derivative should include 0 in one of those places. Do we normally include 0 or include the flex point on a derivative of an absolute value? Yes, no? No, you don't. Why don't you? Because that's what you told me to do. I don't know why. I just don't. Why don't you? It's supposed to be a sharp turn, right? Typically, when you throw absolute value on something, the derivative from the left and the right, there's a sharp turn there, there's no smooth. But what do you see about the derivative at 0? What is the derivative at 0 here? -2. What's the derivative at 0 here? It's smooth there. It's not a sharp turn. It should be included in one of the places. Okay, that's a bit of a fine point. That's to separate the great from the greatest kind of thing. All right. Let's go to the backside. The old score problem, which I know this is going to give you, but I'm kind of looking at this at a different angle. So here we go. You have this piecewise graph, and tell me. So this is the derivative. Let's call it f prime. Although I think originally it was a velocity graph. We'll just look at this some basic derivative. All right? Tell me, why must the original function have been continuous? Why is the original function continuous? Because the derivative is defined. Yeah, the derivative is continuous. Do you agree that the derivative is defined everywhere? That must mean that it was completely differentiable. Now, could it have been completely differentiable if it wasn't continuous? Okay, so because the derivative exists everywhere, f was differentiable at all x, so it must have been continuous. Okay? If I asked you, let's just lay it over the top of the function derivative graph. If I asked you to sketch f prime, would you do so, please? That's f prime. Would you sketch f, given that I'm telling you f of 0 is -10? Now, it's a sketch. You're not going to know exactly how high or low it goes, probably, but you should be able to tell me the shapes.
Can we say that it was differentiable at all x or just for 0 to 18?
Oh, you're right. All x in 0 to 18. That's true. Good point. That is a overreach. Oh, there's sorry. Well, that's for you. I don't know what my phone is. Feel free to talk it over. You guys are so lonely in the math endeavors. Yep. In what fashion? Let's wait. That's actually not. What's the shape of the graph? I definitely agree that it's. You want some water? I actually don't want you drinking out of my water. But feel free to go get some water. Somebody, Connor. A little pat. All right. Talk to me about time 0 to time 2, or x 0 to 2. What's the graph doing? Increasing. What's the shape of the graph there? Concave up. What specifically? X. This is, what's the equation of that line? Oh, a slope. 10x, yeah? What's the antiderivative of a linear? 10x. It should be parabolic here. It should be parabolic like this. How high? I don't know. Okay, I could get into it, I guess okay? Yeah, I was just messing with you. All right, so parabolic up to 2. What about from 2 to whatever the next time is? 8. Is that you? Is that you? I don't know. All right, linear with positive slope or negative slope? Positive slope. Specifically, what slope? The derivative is 20, so it's got a slope of 20. So it's going to have a slope of up 20 over 1 till x equals 7. Then what's the shape of the graph from 7 to -10? Concave down. It is concave down. It's a parabola opening down. Here's the gotcha. Is it like this? Why not?
That's sharp.
Sharp? All right, so first of all, it's sharp. That can't happen. It should be smoothly, this should be smooth here, by the way. Smoothly transitioning. Okay, good deal. It should be smooth because the derivative exists. Do you agree that the antiderivative here is negative x squared? Yeah? That's one component. But you also see positive derivatives and negative derivatives. So the function should be increasing, then decreasing. So it should actually go now like this. Okay? Increasing to decreasing in a downward opening parabola kind of way. Isn't this fun to think? What about in this region from 10 to 14? Slope of negative 10, smoothly sloping negative 10, however long, sorry about that, till you get to that point. And then what about here? Shape of the graph, concavity, and what's going on? Okay, this is linear, so the antiderivative should be ... Parabolic, opening up or down? Up, because it's a positive x antiderivative, so a positive parabola. But as far as increasing, decreasing, decreasing, 0, increasing. Till here, and then the slope is, or the graph goes linear and stays like, isn't that a humdinger? That's some good thinking right there. Imagine there were open, oh man, this might be a little bit of an overreach. No, that's okay, we're cool. We're super smart. Imagine there were open circles at the sharp corners. So here, what would that imply? The derivative doesn't actually exist there, so it's either it's not differentiable there, which could mean it's sharp turn. Now it's not sharp turn because the slopes are pretty much the same on either side, so it must be discontinuous. So couldn't this be something like a positive parabola and then a disjointed line and then maybe a disjointed parabola and then on this piece here, some kind of line, and then a disjointed parabola, and then some kind of line. In other words, my point is, the derivative wouldn't have, or the antiderivative, the original function, wouldn't necessarily be continuous. Are you with me? You'll thank me when you get to the final, because that's the lowest averages on the final, that question. All right. Find the piecewise function given the initial condition in B. So this is the hardest part. People anti-differentiate piecewise badly, especially when you're given an initial condition. So we know, or we can find let's go with here. Let's write the derivative equation, please. What's the equation for all the pieces that you see in that derivative graph? What's the equation for this, please? 10x. Do you all agree? 10x that's from 0 to 2. Okay? Here? 20 from 2 to 7. Here? Down what? Down 30 over, no, down, what is that? 10? Yeah, down 30 over 3, so slope is negative 10. That's great. What about the piecewise component to it? Times x minus, okay. Right, is this just y equals negative 10x? Is it that simple? No, it's far more complicated. So in a point slope fashion, please now write me this equation. Y minus 20 equals negative 10 times x minus 7. Now obviously in a piecewise we can't leave that 20 over there, so I'm talking with a rearranged piecewise. Move the 20 over. 20 minus 10 times x minus 7. Are you tracking here, people? Okay? And that's from 7 to 10. Lee? Probably should have done less pieces. What about the next? The function? Negative 10 from 10 till 14. And last but not least, actually still more two more pieces. Oh my goodness. What's the slope? What do we got? Up's 26 over 26 over 2, so the slope is 13. What about the piecewise component? 13 times what x's and what y moved over? Times x minus 14. And what about the y? Shifted over, moved over 10. We? All right. Last but not least, what else we got? A horizontal line of 10 from 14 till 18. Now that was actually the easy part. Doggone it. Here we go with the integrate.
Wait,
Yep.
why?
Can be from 14 to 16 and 16?
Yeah.
14 to, I didn't do a domain here, sorry.
Why is it positive?
This is 14 to 16. This should be positive 10 because when you write the piece, it's y plus, you're saying it should be negative. You're right. Sorry about that. 14 to 16, going too fast. 16 to 18, do you concur? Cool. Okay then, here we go. When you go to integrate this, you should start with where you have the initial condition. We have an initial condition of f of 0 equals greater than 10. So, if I were to find f of x, this first branch here is to integrate negative, let's go from 0 to 2. F is the antiderivative of 10x, right? That's negative 10x plus c. And if we use the initial condition, it gets us something like 2 equals 0 plus c, so c is 2. And our first function is f is negative 10x plus 2. Yes? Are you with me? Are you with me? You're not with me? Because I didn't integrate 10x, is that why you feel like it should be 5 halves x squared? Okay, thank you. Or just 5x squared, yeah. Sorry, you're right. That's better? Do you agree? Okay, thankfully, here's the payoff. The initial condition for the next branch is special. F of x now is the antiderivative of 20, and that obviously, hopefully, is 20x plus a new constant. I'll call it C2. What can I put in? Let me give you a hint. It's not 0, 2. You cannot use 0, 2. Why not? Yeah, you have to use the point where the other one left off at. Okay, so where did this branch leave off? When we got to 2, this branch ended at, f at 2 was 22. So as far as the initial condition you now use, you go where the previous branch left off, not 0, 2, because this is not defined at 0, 2. It doesn't hit x equals 0. It's if you just ignored the middle piece altogether, you can't do that. You have to pick up where you left off. All right? So in terms of the initial condition, it's 22 equals 20 times 2 plus C2, or C2 is, hello? 22 minus 40? Negative 18, okay? So f of x for the second branch is 20x minus 18. Those should be continuous. They should meet at 2. And if you put in 2, you would see that they do come out to meet that. Okay, they must meet. Now, this one left off at what point? 7. Where it left off, then the y value it left off at was 140 minus 18, or 122. I don't know why I put a negative there. All right? So when you go to the next branch, we'll just do one more to make sure you get the gist. Okay, what is the antiderivative of the next branch? And the next branch is the antiderivative of, what do you got there? Isn't it negative 10x plus 90, if we did a cleaned up version?
Yeah.
Okay, so if I anti-differentiate negative 10x plus 90, then I get negative 5x squared plus 90x plus a new constant. And I use where the previous branch left off. So the y value started at 122 when x was 7. And I get a big mess. 122 equals negative, what is that, 245 plus 630 plus C3. C3 is, let's see, 122, what do we got there? 430 minus 15 more, 385?
Yeah.
Positive. Minus 385, 122 minus 385 is negative 263, if I'm not mistaken. Correct me if I'm wrong. Okay, so the next branch is f of x is negative 5x squared plus 90x minus 263. Do you need to try one piece on your own, or you get the idea?
I have a question. Is this an actual question on the test?
No, this is my question. Okay, yeah, you wouldn't have to do all this. Maybe a little crazy, but you get the idea. Okay? All right. Yeah. How many questions do you have on last night's homework? At least 2. All right, we'll leave this go. This is a good one. It's kind of like the Janet shoveling the snow off the driveway problem, which we did first semester, and it was not good. But I'll make it a warm up tomorrow. Questions on set 90, 136. 19. Maybe 25, but maybe not. Who's to say? 19 must have been a good. Yeah, 19 is a good one. Okay, here we go. 19. You might have figured this out on your own, and you weren't sure if you were doing it correctly, but this is improper on so many levels. Won't you agree? Okay. So you're talking about an integral that has an asymptote at 1, or a region that has an asymptote at 1. And it looks like this. And so you're talking this region, and forever this region. So, first and foremost, we'll need a limit at A, representing the approach from 1 from the left. So I'm going to call this the limit as A approaches 1 from the left, from 0 to A, of x minus 1 to the negative third. Cool? Then I would need to create a B that can approach 1 from the right. So the limit as B approaches 1 from the right, from B to, now here's the gotcha. You can't go to infinity, and you most def do not do two limits next to each other. You don't do that. So what's to be done? Just pick any number. Let's call this 5. Okay? Now, could you tell me the area from B to 5? Sure, it goes from B to 5. There you go. Okay? And then finish it out by letting C go to infinity. Now, 5 is obviously totally arbitrary. Oops. You could have done it at anything above 1. But from 5 to C. Does that get you started, or shall we continue with the answer here? Keep going? Or no? Thanks, Jack. I appreciate that. Okay. Anything else on 19? Or on 136, rather? Cool. You guys are the champions. Oh, there's not 119. Darn it. Oh, well. There we go. We're ready. We're done. See, you could have done the problem. Oh, well.
Oh, mine is 25.
Here we do. X equals 4. So, 5, y equals x squared plus x minus 2, which is x plus 2. It's revolved around x equals 4. Okay, so please tell me you used x as your variable because it's not a function of y. Okay, so shallow washer disk. Shallow. Okay, so I would bet anything that the error comes from the 2 pi, the radius. What's the radius of each slide, of each what did you say?
Is it 4 plus x?
It's 4. It's 4 minus x. In some cases, the x is negative, so that's why it extends more than 4.
So does it go from 1?
So 0. Oh, the limit? Negative 2 to 1. It's the original region.
Okay.
And 0 minus, don't forget to make your height positive. Otherwise, you'll get a negative volume. Those are usually glycemic. Okay?
Because I'm like estimating what we missed in a while.
Okay. I'm full.
Sorry. For Montrell.
So you're saying it's support.
If it was up to me, I would think I would.
Are you pretty good? Are you a good arguer?
I'm a witness, actually. So I'm a good liar.
Okay, there you go. That's good to know about my students. Is this tomorrow?
Yeah.
I don't know if I have it.
I can print one out.
I don't know. That's where you put the missing.
Let's do it. I don't know why.
Oh, yeah, there's one more.